And rise, you subtract the y's. Run, you subtract the x's. All right, and then the slope template looks like this. Slope template looks like this. So now ready, I'd like you to pull down the slope template right here. Pull down that slope template. And ready, I'd like you to find me the slope between those 2 points. Y minus y over x minus x. Y minus y over x. Never got L. Okay. Yeah. You got y minus y over x minus x. And it's negative 25 over 8. It doesn't matter where the negative is denominated. And it's negative 25. Okay. All righty, guys. Ready. Now, last night we covered these 2 basic concepts. I have a challenge for you guys. A quick challenge. And the concepts that get included somehow, some way. And what is the relationship of perpendicular lines and slopes? On Wednesdays, I want you to watch for this one problem that includes one of these concepts. If there is not, you the concept is somewhere on there. Today in your today I've given you 3 SAT problems. I'll put them out to you. And graph these 2 lines as quick as you can. Colby, seat down, please. Okay, now go back and circle the slopes, please, very carefully. Out loud, these lines are what to each other, out loud. Parallel, exactly right. Put your little arrow feathers on there. Okay, now look very carefully at the slope. Circle them. Tell a neighbor, what do you notice? That's the easiest one to remember. Parallel lines have equal slopes, which makes sense because if the tilts are not the same, then they would not be parallel. So slope equals. That's the easy one. A little bit more interesting is this one. Start graphing these 2 lines. Look up when you're done, see if you're getting the same thing. You guys getting the same thing? You graph these guys? Let's take a look. So the green, you start at +3, you go up 2/5. It's a positive line. The purple, I start at -5, and I drop 5/2 to the left because it's a negative line, or I go up 2 and left, up 5 and left. So what to each other? Make a big fat right angle in there. Big fat right angle. Now circle the slopes. And in the top margin, I'd like you to multiply those slopes. Multiply them. Multiply those slopes, please. Multiply them. Remember, when you multiply, you go straight across. So technically, that's -10/10, which is just a big fat what? And that's -1. That's true of all perpendicular lines, is the fact that the slopes multiply to -1. Okay, that is very common. Now, warning, SAT has a classic, very classic trick question. Trick question. With one arm, show me zero slope. Show me zero slope. Now, using your other arm, show me no slope. So, are these perpendicular? Zero slope, no slope. Are these perpendicular? Yes, that's your. Show you what SAT is going to toss you possibly. Okay, so a zero slope line and an undefined line are still going to be at right angles. Let me show you what this usually looks like. Ready? I like you to draw this, and this line is y equals +5. Y equals +5. That blue line, is that zero or undefined? This blue line, is it zero or undefined? Zero. Great. So an example of a zero slope is y equals 5. In fact, that's true of all y equals lines. Y equals anything is going to be zero slope. You ready? Now let's do this one right here. Let's put that's an x. Let's make that x equals -2 line. What's the slope of the green? Out loud, guys. Show me with your arms. What's the slope of the green? Show me with your arms. Yes, undefined. So any x equals line is going to be undefined. Now, here's a classic SAT question, like what they call a trick question. Ready? Take a look at here. I'm going to give you a line. The line is y equals -6. Box it. Question is this. What's the perpendicular slope? I want you to write it. Y equals -6. I want you to think it through. What is the perpendicular slope to that? Don't say it out loud. Write it down. If y equals -6, what is the perpendicular slope? I want you to ask 3 different. I think that was okay, guys. Now, this is a report what somebody else said. So this is not you. This is somebody else. Wow. 6 is in their answer. Just got bet on an SAT question. Listen what careful. Y equals -6 right? I just told you any equals line is a horizontal line, which means the slope of this. So perpendicular slope is undefined. Okay, turns out it's actually Okay, let's try one more. We obviously need this. Okay, ready? If I have x equals positive 2, what would be the perpendicular slope? Okay, guys, it has nothing to do with 2. If you graph it, it looks like this. X equals 2 is about right there. What's the slope of that vertical line? No, the slope of the vertical, that's undefined. Therefore, the perpendicular slope is 0 slope. Okay, careful with that, guys. That's not the exception. Ready, go to today's lesson. Today's lesson. Okay, go to the right-hand side. Ready? On the left-hand side, we're going to work backwards. This is on your Alex, too. So we're doing a questions. Alex, you guys want lights on or off? Okay, off, sealed louder. Ryan, go ahead. So ready, guys? We are right here. Take the green and the red line, and I'd like you guys to find, please, the equations of those lines. Find the equations of those lines. So the red and the green. You are finding the graphs, and you are writing it down. Notice I'm finding the intercept first. Count out the slope. Okay, when you're down, see if you're getting the same thing. Guaranteed something like this is on the test on next Tuesday. Guaranteed. I'm sorry, my test. This will be. Sure. Oh, your test is next. That's fine, Dave. That's the same thing. But you have to recognize both. Okay, ready, guys? Look up here. What do you notice about the slopes? Okay, so we notice that about the lines themselves are parallel. That's what we notice, this fact that the lines are parallel. So you could just use this thing here, parallel. Okay, and what do we notice is going on? We notice that slope equals slope. I went pen, not highlighter. You could say there equals, sure. Slope equals slope. Ready? I'd like you to do the right-hand side. Do that one yourself. Find those equations, answer those 2 questions. Should take you about a minute. And then I'll show you the answer. Do that yourself. Do the purple and the green. Do the questions, yes, and answer the questions. Okay, ready? Check. Okay, so the blue is going to be y equals 3 plus x plus 1 times on you said they're perpendicular? Okay, and then the pattern going on is they multiply to negative 1. If you call them the opposite, that is fine. No, they have to multiply to negative 1. That's fine. They multiply to negative 1. So just realize, guys, this one's really easy. You have to make sure it's the opposite reciprocal. So we have 3 over 5. This is negative 5 over 3, negative 1. Okay, that probably won't be on the PSAT. It's too easy. Let me give you a classic SAT question. That was way too easy. That's just warm-up. This is more likely something you'll see. Ready? I'd like you to finger track and read this out loud from there to there. Go. With a show of fingers, how many lines are we talking? Two lines. There's what's called the given line and the derived line, which means you do something with it. Let's start by simply graphing our given line, which we have right here. Okay, graphing our given line is going to be y equals negative 2/3 x plus 2. And then we graph it down below. Is it minus 2 or plus 2? Plus 2. Turn the page. Okay, so at positive 2. Count out the slope. Always write your equations down. And that's going to be line M. Now, our line P has two qualities. Very, very carefully. Quality number 1, line P is what to M? Okay, guys, what is it out loud? Okay, below number 1 there, that's quality number 1. It's perpendicular. Quality number 2, it goes through what point? Okay, now there's two ways. We want the slope-intercept equation and the graph. There's two ways to get that equation. One is graphically, algebraically. You must do both. Let's do it graphically first. Ready? Plot the point -6, -3. I need you three to rotate forward and not say a word to each other for the next 45 seconds, okay? -6, -3. Now, our slope of M is -2/3. So the slope of P is the switch and flip. So it's going to be 3 over 2. You okay with what I just did? So from that point, count that slope out a couple times. And graph your line. That's P. Okay, to get the graph method, let's take a look here what we have. You graph this really carefully. At what point does it cross the y-axis? What point is that? This point right there. What point is this right there? What point? That's a 6. Okay. So we have a 6. And our slope was positive 3 over 2. Whoa, 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 whoa. What? Parker, talk to me, buddy. Okay, because look where it crosses the y-axis. That's 5, that's 6. The y-axis, yeah. Okay, there is our equation of the line for P, offset, and just like that. You see what we did there? Just one the point, we counted out the slope. Yes. All right. But you have to be able to do this algebraically as well. Emma, I see question mark above your head. What's up? Okay, I will go over this with you in just a moment. Okay, now algebraically, we have a point negative 6, negative 2. The desired slope is 3 over 2. So this is a point and a slope. Say point slope. So to do this algebraically, we use the point. Why did I choose that? Because that's the point and slope. Those blanks I already filled in. Okay, ready? Now, draw an arrow from here. Step number 1. That's an excellent. That's going to be right there. Let's put a negative. That's our y1. Goes right there.
Bless you.
And that's our slope. It goes right there.
Bless you.
Charlie, you okay with this now? Okay. Okay. Ready? Bring everything else down. We have y. Look, that's going to be minus. That's going to be a double negative. Minus negative 3. Minus negative 3. Flip that to a positive. X minus negative 6. Change that to a positive. Okay, our job is to get y by itself, so we're going to distribute this first. Okay, for those of you who need to see what 3 over 2 times 6 looks like, it's right here. 3 over 2 times 6. 2 goes into 6 3 times, so this becomes 9. Ready? Last little step here. We have to minus 3 both sides. Get out of my fat pen here. And there's your algebraic. If you look really carefully, your algebraic should match your graph. Your algebraic should match your graph. You see that? You have to be able to do it both ways. The reason why, Colby, is the SAT may not do the graph to work with. You have to be able to do that algebraic. Some people it's easier to do on the graph. Okay, if what I just did confused the daylights out of you, I want you to roll forward. We'll do one more together. Everybody else start working on 4. If you want to do one more of these, roll forward. Which one, sir? Okay, you want to do one more with me? Come on down. You want to do one more with me? Come on down. Okay, we'll work. We'll do problem number 6 together. You want to do one more with me? Roll forward so I know who you are, so I know who I'm talking to. I don't want to shout at the whole class. Everybody else work on page 4, guys. Okay, raise your hand if you're going to do problem 6 with me. So who am I talking to? I'm only talking to 3 people? Really? Justin, you want to do problem 6? Okay. Cole, are you going to join the party or are you just doing your own thing? Okay. Anybody else? So? Okay. Mitchell, you guys are okay in the corner there? You good, gentlemen? Got it? Okay. Okay. Ready. Let me do a quick little rounds. I want you to finger track and read this yourself. Finger track and read it. And then I want you to graph the given line, which is line M. So first read and then graph just this line right here. Just that one line, that one right there. It just disappeared. Sorry about that. Okay. So read it, lips moving, and graph that. Go. Read it, lips moving, graph that.
What time does school start Wednesday?
I think we start at 9. There's a break in there somewhere, but they're short. And come with something non-digital to do. Like you're not allowed to have your iPads or cell phones out ever for like 3 hours. So bring a magazine or a drawing. No digital electronics. Nothing digital. We're talking about a book, magazine, origami, Play-Doh, stare at the wall and drool, whatever. Why not? As long as it's non-digital. No, absolutely not. No digitals whatsoever. Patrick, what? Sure, as long as you don't snore. What? It will be in classrooms. You'll have assigned classrooms. On Wednesday, they'll show you. Y equals negative 3x minus 2. Okay, guys, so we go like this. We have the y equals negative 3x minus 2. That's line M. So you start by graphing that. Okay, so start by graphing, guys. You can do your own graphing. Here's negative 2. Is it negative? Okay. Drop down 3 over 1. It's a negative line. Up 3. 1, 2, 3 over 1. Negative 1. Did you graph this already? You guys got it? Okay. Okay, so that's line M. Now, line P has 2 qualities. Line P has 2 qualities. Okay, Cole, give me one of the 2 qualities it has. Line P has 2 qualities. What's one of the 2? Parallel. So it's parallel. So if our given slope is negative 3, Christina, what's our parallel slope have to be? Okay, it's parallel now. It's the same thing. Got it? Because parallel lines have equal slopes. So our first quality was the fact that it's parallel. Parallel. Taylor, what's the second quality? Not only is it parallel, it also what? Goes where? No, it's parallel and... Sweetheart, I'm giving you a hint. It goes through, Taylor, can you say the word through? The point what? Great, so it's going to go through the point negative 3, 1. So let's bring that down here. It has 2 qualities. Quality number 1, its slope has to be negative 3 over 1, and it has to go through the point negative 3, comma 1. Now we do this graphically and we do it algebraically. Step 1, we do it graphically. So plot the point negative 3, positive 1. I'm helping in number 6 right now. I'll be there momentarily. Okay. Now, Andra, what's our slope that we're going to count out? So from there, we're going to go drop 3, go over 1, or we can go up 3, go over 1. Do you see what I just did? You okay? So here's your point. Right there. See that black point? Now you want to very carefully graph this line. As carefully as you can. Because if you don't graph it accurately, it's going to throw off your equation. That's why we have to confirm it using algebra. Okay. Ready? Emma, question to you. Where does this line cross the y-axis? What point? What? Positive or negative, ma'am? Okay, so it's -8. And then the equation was y equals 3 over 1 x minus 8. Do you understand? That's the green line. Box that and write the word graph. We got that from the graph. So are you okay with that? Okay. Now we have to do the algebra too to double check because you have to be able to do it both ways. So we're going to go like this. Y minus y1 equals slope x minus x1. It's right there. Ready? Okay. Now we're going to plug them in. This -3 is going to go right there. This goes right there. And then the slope goes right there. Bring down the equation around it. You just plunk it in. Yeah, there you go. This is a double negative, becomes a positive. Okay. Now we do this. Distribute. Dustin, what's -3 times +3? Bingo. Taylor, how do I get rid of this negative? Okay, so I'm going to add 1 to both sides, and let's see what happens. We end up with y equals algebra. Okay, now question. Does your algebra match your graph? Ta-da! If one of them's wrong. You either go back, check your algebra, or check your graph. Yes, ma'am. You want those to match. That's why you do both.